right, so this is part 3. So now we're actually going to create a probability distribution. Okay, so first thing we want to define is a probability distribution P of x. So again, this is a probability, but we're going to define a little bit different here. So it is a description that gives the probability for each value of the random variable x, right? Or in other words, the relative frequency. So notice a lot of this we've done so far, we're just going to call it something different now. And here is a complete example of what it means going down the column. Notice I said earlier all the examples were across. This one also goes down as a relative frequency. You can see it. So here it says the shots in a basketball game is a random variable x. So the number of shots in a basketball game. So in this case, we are going to 0 all the way to 4. And respectively, we have the P of x respectively going across. Okay, so meaning the probability of 0 shots, so the probability x equaling 0 is 0.2, right? And then you're just going across. The probability, so that's how we write it like this. So instead of in words, that's how we write it. So the probability of 1 shot, so x being 1, is 0.16. So again, we write it as P of 1 equals 0.16, right? So x is 1, and I'll use to associate the number to the actual probability itself. Okay. So, and then, goes on and on and on, right? So now what we want to do is we want to create this ourselves, okay? So again, go ahead and quickly pause it and try it. So give it a frequency distribution where the pulse of movement is x, right? In other words, you want to convert this, a frequency distribution, to make it look like that, okay? So now I'm going to give you a little start. So instead of saying pulse rates of movement, now this now becomes x, and this now becomes P of x. So remember, the way we find the P of x is literally finding the relative frequency. So again, if you guys forgot, add them all up and divide every one of these by the total itself. So again, you guys go ahead and pause it real quick. 3, 2, 1, and try it yourself. Go for it. Okay, so hopefully you guys tried it. So the total should give you 40. That's what I got. Hopefully that's correct. Total 40. So now I'll divide everything by 40. So we have, so these x's are going to be the same. So 60, 70, 80, 90, 100, 110, and then finally 120, right? And then the individual, so 12 divided by 40 is 0.3. 14 divided by 40 is 0.35. 11 divided by 40 is 0.275, and then 1 divided by 40 is 0.025. So 0.0225, 0, and then another 0.025 for the last one, right? So this one has 0 there. So that should be your answers there. Okay. All right, so that's the first step. Now from there is just basically answer questions, right? So basically, now that you created this, can you answer some questions off that? So question A says, find the probability of x equaling 70. So with x equaling 70, which is right there, what's the probability? We'll just go across. That's going to equal to 0.35, right? What that's saying is, what's the probability of the pulse rate being 70? 0.35, right? You just literally just now go across. So basically, once you have this table, you just answer questions based on the table itself. Notice again, this is just like one of your questions on your exam, and also your homework, right? So nothing really brand new when it comes to it. All right, but now we're going to introduce a couple things. So notice it has an inequality there, right? So we want to find the probability of x being less than or equal to 90. Okay, so less than or equal to, that means smaller or exactly the same as 90, right? So here's 90, but I want everything that or below, less than that, right? So everything below it. So I'm going to add everything from here down, right? That's going to be my final answer. So if you add everything from here down, because that's what, like, everything less than that, well, what's all this added up to be? And it should give you 0.95. So just for a little practice, why don't you guys try B real quick? We'll do E and D respectively ourselves, but let's try B. Go for it. 3, 2, 1, pause it. Okay. All right, so now this will want x is greater than or equal to 100, right? So everything 100 or more. So 100 or more is right here. So we're just going to add a couple more things. So we're going to add all of this up because everything is, or actually opposite. What am I talking about? Greater than. So x is greater than 100. So it's opposite. Everything from here down, right? So this, this, and this. So both of these together. So this should give you point what? 0.05 total, because you want everything greater than 100. Okay. All right. Now let's look at D and E respectively. So D says is at most 110. So unfortunately, we didn't have class. I always like kind of screwing you guys, see which was the inequality itself, because it's like split in half when it comes to the class. It's this and that. But at most is we got to figure out, is it going to be less than or equal to or greater than equal? That's what we got to figure out. What does the at most actually represent in this question? Okay. Now, since they want at most, that means it's going to be the largest value itself. So it's actually this one. So I can rewrite that as x must be greater than, no, sorry, it's the other way. Less than. X must be less than or equal to 110, because it's at most, wait. Yes, it's at most, sorry. It is at most 110. Had a brain fart there. Yeah, so it's at most 110, so X must be less than or equal to 110. So now we go up here. So what's everything less than or equal to 110? So that's from here all the way down. So it's adding from 0 down. So if you add all those up, it should give you 0.975. Go ahead and verify that real quick, okay? So now we do the opposite. So E says, find the probability of X is at least 70. So again, we got to figure out, is it going to be one of these two? So is it going to be this way or that way is the question. Well, it's the opposite of the at most. Is at least means it's minimum of 70. So we're looking for the probability of X being greater or equal to 70, believe it or not. So therefore, since we want everything 70 or above, we go back over here. So from 70 or more, right? So 70, 80, 90, all the way down, meaning we're adding all of this together now. So we add all of this together, that's going to get equal to what? Should give you 0.70, I believe. We add them all up itself. Okay. So that's how we're going to do probability distribution. So first off, we're going to convert it to this, and then I'm just going to ask you questions based off what you just wrote down, right? And it gives, it could either be equal to, it could be inequalities and stuff like that. Now, when it comes to this, if you guys want more practice, we're going to talk about this in probably next week. But if you turn to page 75, which is that portion, I summarize it right here for you guys. Okay, that's a quick summary of what all the ones we're going to do. So this is at least, at most, more than, all that fun. And it corresponds to the inequalities. Okay? So that's on page 75. Okay? So you guys can always use that to help you guys out when it comes to it. Okay? Right. Okay, so this is it for this video. In the next video, I'm going to give you guys an example how to do this. So this is just, this is the end of the actual section here, right? But I'm going to give you guys two examples to try, on your own, and then we'll do it together as well. So this is it. So next page is, 5.2, but this is the end for just section 5.1. Next video will be actual practice problems based on this information, okay?